Hello, I'm Geovanny Brambila, and this is the artificial blood vessel design and experiment given to me to design and experiment a blood vessel with a certain length and material to really understand as to what choices to make when replicating the human blood vessel and the advancements in the engineering sector when it comes to um, the human body. Uh, to begin, the human blood vessels would be a very serious um, replication and application. So, chosen parameters have to be um, carefully researched. That being said, to start off, a blood flow rate of 5 liters per minute is what was decided to be the average human blood flow rate, but stresses of about, or no, flow rates of up to 25 liters per minute can be tested just to make sure and understand that these materials can sustain stress and strain through different pressures on their walls. Um, the other more important per se specification would be the diameter, which is 2.14 millimeters in average as well, through the human arteries and vessels. Uh, Moving on to the three materials being PCl, PLCl, and EPTFE, which are and would be the more researched materials in this sector. EPTFE being the most, which we will get to in a bit. A brief history about these materials and artificial vessels in general would be that Voorhees in the 50s actually created autographs of animal tissue and artery to understand and be able to apply, mathematically um, to understand as to what they sustain and how they function in a human uh, body. Um, PCL and PLCL would be the engineering breakthroughs in the early 2000s in terms of materials that could replicate a human blood vessel, but the EPTFE dates back to the 60s in material research. So it's a pretty serious material to be choosing, but all three are good and very well known materials in the biomedical uh, environment when it comes to blood vessels. When it came to the study and application of the stresses and the flow rates, um, parameters also had to be given. We were given a millimeter, 10 millimeters, and a 100 millimeter blood vessel to really understand these stresses and strains within, well, certain blood flows. Um, that being the 5 liter per minute and the 25 liters per minute being 5 times the amount of the average human. Wall thickness was kept at 0.05 millimeters to really hone in on that certain, really specific blood vessel, I guess, that could be universally used within the human body. And each configuration went through a stress and strain, fluid flow simulation. That be the three lengths: 1 millimeter, 10 millimeter, 100 millimeter, on the three materials, that be PCL, PLCL, and EPTFE, at the two blood flow rates. These were certain results. I chose EPTFE because, like I said, the most researched, usually the most looked out for when it comes to uh, the human body and its pretty much usage within this human body. Um, that being said, the 1 millimeter, 10, and 100 showed a good a good understanding as to how the material really functioned within the body, or how it would function within the body at those certain flow rates. These are being flowed at the five obvious average liters per minute, um, but the yield strains and yield stresses never budged what what they never exceeded what was meant to be. So they all passed the test. So every single material did pretty well when it came to the stresses and strains, um, and it just came down to uh, the cost. PCL, like I said, they often all failed within obviously a longer length, and much more than that, just a faster blood flow rate. Uh, to end, I would recommend EPTFE, not only because, like I said, it was the only one to not stay well below its yield strain, which was at 70% for the highest. But not only that, it far exceeds the cost. Whereas the other ones were going from $5 to 25 a kilogram, these would go no. Whereas the other ones were going $50 per gram. This per kilogram goes $5 to $25, and it also comes in its own tubing design already, at different millimeters, different lengths, um, and these, like I said, have already been studied before and are known to be pushed to limits where a human body, like I said, can 5 times push a blood flow rate, and really um, pretty much understand where this material lies within this research. Yeah, that's about it. EPTFE, good for blood vessels. Oh, that shit was